So right now I'm going to walk you through an example that's similar to one that we did in class. And as you can see what's written here, I want to know what's the area of that red region. And what you need to do here, you need to do something called finding a difference of the two areas. And so I'm sure there could be some formula you could work out to get the precise area of that red region. But for now, we're just going to do it by essentially finding the area of the large rectangle. So I'm just going to write that as area large minus the area of the smaller rectangle. That's how you're going to find the actual area of that red region. Now, let's start off with the large rectangle because that's the trickier of the two. So if I'm going to, let me change the color of my pen. If you're going to find the area of the large, you're going to have the accurate side length. So we have two expressions here to describe the side lengths, but the actual expression that we need is the length of this entire side, and then I'm going to draw through this, but the length of this entire side. And so what we have there is that in order to get that, we have to add x plus 5, that's the bottom one. And then I guess the width, the height, would also be x plus 3. Now that might look a little weird, it might look a little confusing, but you have this segment x plus 5 and you have this segment x. That's how we get the length. And then for the height, we have x plus 3 as this segment, and then the other segment is just x. And so what we have here when we combine these is we have 2x plus 5 would be the expression length of the bottom one, and then 2x plus 3 would be the expression length of the width or the height. And now we can just FOIL, so I'm not going to write it all the way out, but you can turn this into what becomes 4x squared. The outer terms would give you 6x, the inner terms would give you 10x, so this would be 16x plus 15, okay? So we have that for the area of our large rectangle. And let me change the color of my pen again. Now we need to find the area of the small. The area of the small is this length times this width or this height. And so I can write that over here to the side. This is equal to, if we were to pair these up, so that first 2x plus 5 for the larger rectangle, well, if we want the smaller rectangle, we just take the x out. So the length of that is x plus 5. And to get the width, we can take that x out. And so that's just x plus 3. And so what you end up with when you FOIL this will be x squared plus 8x plus 15, okay? Now we can do, I'll write it in red ink, we can find the area of a shaded region. Because we have the area of the big rectangle. The area of the big rectangle was equal to 4x squared plus 16x plus 15. And we are going to be subtracting the smaller. And so this came out to be equal to x squared plus 8x plus 15. And when we combine these, we end up with our correct answer. So 4x squared minus x squared is 3x squared. 16x minus 8x is going to be 8x, and then the 15s would cancel out. Now, one thing that I did kind of skip that I showed you earlier was to make this addition and to turn these all into subtraction, but as you can see, 4 with a negative 1 is 3, 16 with a negative 8 is 8, and then 15 with a negative 15 just goes away. It would be 0. But anyway, that's an example, and hopefully it helps.